Okay, but then let's start from this 2021 January this one paper. That's what to understand. If you come up with this, the first question, the Venn diagram shows an event ABC and associates it with probabilities. Right. Then the first case is you can understand that when you come up with A and C, there is no intersection between A and C. Therefore, yeah, if sometimes they might ask these questions, A and C are mutually exclusive because there are no intersection between those two. Right. Okay. Then if they want to find probability of B dash, probability of B dash in the sense is they are talking about the area which is outside from B. That is what you mean by probability of B dash. Can this part of it? So B is this bit. If you take up a probability of B is that. So out from this area, totally area where it's outside from this is, it belongs to this, this and this. So simply you can get this answer 0.15 plus 0.13 plus 0.12. So your final answer would be 0.18, 0.3 would be the final answer for this. 28. Sorry, 0.4. 28, yeah, 0.4. The answer for that. So simply you can get. Then the next fact we are talking about is we need to see whether probability of A union C. A union C means everything belongs to A and C. So if I just get it, A is this bit. So nothing to worry about the other intersection. They are just concerned about A union C. So you just color A and C. Everything over here. Right. Here it's turned up to 0.15 plus 0.2 plus 0.23 plus 0.12 would be the final answer for this. If it's turned up to. It's turned up to 0.70. See, it's A given B dash. Means if you write the formula, it's turned up to probability of A intersection B dash divided by probability of B dash. We already found this probability of B dash over here in the first part of the question. A intersection B dash. Okay? The B dash area we know. B dash means if you just get this answer, if I write with the different color, B dash is outside B. If you cannot understand what is the area they are referring to, you just color B dash. When you want to get the regions without understanding or without just marking any kind of, without concerning the in-between operation, you just color B dash. B dash is this area, not a problem at all. Then color the other area, A. The operation here is intersection. Intersection means see whether what is the area which shows these lines intersect into each other. So you can say this is the area where, if I concern about this, but this bit, so it could be this is the area where it's concerned about this. So you can say this is 0.15. So it's turned up to 0.15 divided by 0.4. The final answer is 0.375. That would be the final answer for this question.
So we always have.
The stem leaf diagram below shows the ages in years of residents in care home. Right. The stem leaf diagram below shows the ages in years of a student in a care home. So in this case, here the age is 43, 54, 62, so on. So this count gives you the total number of members in that care home. So I will get a rough count on that. So it's 2, 11, 22, 22 plus 9 is 31. So 31 would be the value over there. Right. Then find the median age of the residents. If you want to find the median, we know that if you work out with this, median is n divided by 2 theta. It is 31 divided by 2, it's turned up to 15.5. So we want to get the 16th data. 16 data. What is the 16 data is? That is the fact we need to understand with this. So that is 16 data is, you can say this is 1, 2, it's 11, 12, 13, 14, 15, 16. It's turned up to 74 is the median age over here. So that's the answer for part A. Part B is find the interquartile range. To find the Q1 would be n divided by 4 data. That is 31 divided by 4. 31 divided by 4 is turn up to 7.75. 7.75, that means you have to get the 8 data. See what are the 8 data is 1, 2, 3, 4, 5, 6, 7, 8 is 68. 68. Then Q3 is 3n divided by 4 data. It is 3 times of 31 divided by 4 is we need to get the 23.25 data. That means obviously turn up to 24 data. Now check what the 24 data is. 24 data would be 1, it's 11, 22, 23, 24, it's 80. So if you come up with this, the first quartile is 68 and the median is 74 and this one is 80. So we can have a little bit idea on this, right? Okay. Then the interquartile range, IQR. IQR is Q3 minus Q1. That is 80 minus 68. It's turned up to 12. It's the IQR for that. Then an outlier defined as the value of the value in either more than 1.5 IQR, the lower region, and this one usually that fact we have talked about. Q1 is equals to lower boundary. Sorry, lower boundary is equals to, when you consider about part C, Q1 minus 1.5 times of IQR means Q3 minus Q1. The Q1 is 68 minus 1.5 times of 12. 68 minus 1.5 times of 12 is 50. It's 50. Yeah. Then upper boundary is Q3 plus 1.5 times of IQR. Q3 is, according to this one, is 80. 80 plus 1.5 times of 12. 80 plus 1.5 times of 12. It's 98. Yes, it's turned up to 98. Right. On the grid on page 5, draw the box plot to summarize data. So when you're concerning about this diagram, this is the way you can see that when you draw this box plot. You can draw it at the grid. The lowest values are 54, 43, and 62. So we will be a little bit concerned about these two figures. I'm a little concerned because I will tell you the reason. 43, 54, and 62. These are the lowest set of elements available in this one, and the highest value is 97 and 93. I will let you know what is the reason for me to mark this information. Okay, let's go to the box plot diagram over here.
Sir?
Yes, Pate.
Sir, the only outlier is 43, right?
Yeah, that's what we need to understand. Yes, that's it. Okay. Then what you can understand is, Pate, the lowest boundary is, the lowest possible value. Initially, we'll mark this facts, Pate. It's kind of easy. 68. Clearly, we can mark this value 68. 68. So you can mark 68 over here. Clearly, you can mark it. Then median is 68. Median is 74. Clearly, you can mark over here. Then Q3 is 80. You can clearly mark over here. Now the middle box you can complete. Then what we need to understand is, Pate, we need to go ahead with the lowest boundary. Lower boundary is 50 means, Pate, the minimum possible value you reach is 50. The minimum possible value you can reach is 50, but you can see there is a value less than 50, that is 43. That means, Pate, the 43 become an outlier. This is the point to understand. So you can mark a cross over here exactly on the index. Other than that, you can mark 43 like this. That's a one way of represent if you are sure, not sure of marking this perfectly. Then up to 50 is the lowest, but if they have given specifically the lower order figures, 54 is the next smallest value. 54 is the next smallest value. Therefore, the lower boundary become how much? 54. That's the point you need to understand in this question. If they specifically given the values over here, you have to select the next smallest number as the lowest value. When you concern about the upper boundaries, 90 is the maximum possible value, but available maximum value is 97. So the upper boundary become 97. And if you didn't draw this perfectly, it's better. You can mark this one's 97 and over here as well. 54. Then you have more concern, but if you can just draw it nicely, it's not make a sense with that, or you can do this question much easily, right? Okay, let's go to the next question. Right. Then when we start with this question, we need the normal distribution table. Second, we have to go with that. Right. Let's go back to this question. The weight of a package that arrives at factory are normally distributed with mean 18 and standard deviation of 5.4 kilograms. Find the probability that randomly selected package weight is less than 10 kilograms. Yes, right. Okay, right. So over here, the weight of this one is having a normal distribution of mean is 18 and the standard deviation of 5.4 kilograms. Find the probability that randomly selected package weight less than 10 kilograms. Okay. So you can say probability of WV is less than 10. That's a fact we need to understand with this question. Initially, what you need to do is, we need to make them into standard normal. How to do the standard normalizing? Subtract mean from both sides and divided by the standard deviation, 5.4 and 5.4. With this, you get the answer. Probability of this is turned out to Z is less than 10 minus 18 divided by 5.4. It's turned up to minus 1.48. But usually we know that we don't have the negative probability, negative events. Therefore, multiply both sides by negative with that turn up to Z is greater than 1.48. Z is greater than 1.48. Then greater probability you can get 1 minus probability of Z is less than 1.48. Right. So with this, you can say this is it's way 1 minus 1.48. You can read it from the table. 1.48. 1.48 is 9306. 0.9306. 1 minus 0.9306. That answer becomes 0.06. 0.0694 is the answer for that one. That's pretty simple. Then, yeah, this one. Then the heaviest 15% of the packages are moved around the factory by Jima using the forklift truck. Find the weight in kilograms, the heaviest package that Jima will move. Okay, that's a good question. Then when you concern about this question, they're talking about the heaviest 15 means the weight of a package is greater than a certain value. We need to find this value. This is a 15%. 15% means 0.15. Initially, same way we can make them into standard normal using the same technique over here. Is greater than k minus 18 divided
Sir,
by 5.4. Yes.
so
Yes,
they
please.
say the find of the lightest of these packages.
Yeah, that's a point. That means for the heaviest category. Like, look at this. In a group like this, a very good question you arise. There are packages like this: 10, 12, 13, 18, 19, 20, 22, 24. Like that. It comes like. Okay. Then you need to get the heaviest three packages. You need to get the heaviest three packages, right? So what is the lightest packages out of these three heaviest one?
10.
Sorry, you need to get the heaviest three packages. Heaviest three. Heaviest three. Means what are the packages you need to select as the heaviest three? This
20.
one, this one, and this one. So what is the lightest package out of these three? Is 20.
20.
So we are talking about the lower boundary. So that from, sorry, above than this boundary, there should be three packages. Like that, we need to say whether what is the lower bound for the heaviest heaviest 15% of the packages. That means for all the packages from the lightest one, sorry, out of the heaviest three packages, heaviest 0.15% packages, this should be the lower bound for that. So the other values are, all the other weights are what? Greater than this W. Is that clear?
Yes.
Right. That is how you need to get it. Okay. Then, yeah, the next one. Just like this. Then we have to work out with this. Then we know that for the greater region is, if it is the greater region is 0.15, we can simply write probability of Z is less than K minus 18 is 5.4 is equals to 1 minus 0.15, 0.85. That means if the heaviest is 15%, because we can't get the greater region from the table, if it is so the other region is how much? 1 minus 0.15, it's 0.85 would be the answer for that. So that is how I get this answer. Then see whether 8,500. There are two techniques we can do. The first one is we can see 8,500 from here. 8,500 closest figure for 8,500 is this 1.04. Get it? 1.04. So you can write this is 1.04 is equals to K minus 18 divided by 5.4. So with that, you can get the answer. K is 1.04 into 5.4 plus 18. That is turn up to then 23.62. 23.62 kilograms. Right. Then the next fact. The next method is when you're concerning about this table, there is another table. That is a greater than region table, but very less number of informations are there. Very less number of probabilities are there. Now you can see for the greater region 0.15, it's here. Greater region 0.15 is here. If you want, you can that value as well. Then you can say the second method is 1.8 divided by 5.4, but here there are very less number of events are there, not very much. 1.0364. Now let's see whether does it get any kind of significant difference with these answers? 1.0364 into 5.4 plus 18. That answer is 23.59. So you can see if you round it off to the first decimal point, both the answers get the same significance. It doesn't make a much big difference. Other than that, if they specifically mention, show that. So you can use the whatever the table, it doesn't make a big difference with your final answer. So therefore, nothing to be much panic on that. What is the way you select this answer? So, but specifically if they mention, yes, okay, show that or something, then you might have to go for that table and pick that information. So you have to be kind of concerned about that as well. So that's the answer for this, right? Okay, then for this question. Now this is the important concern, the question, right? One of the packages not moved by Gemina is selected at random. You know that the heaviest packages are shifted by Gemina. If it's not moved by Gemina, means we know that the weight of the package is less than 23.62. because it's not moved by Gemini, because we know that all the packages more than 23.62 is shifted by Gemini. It's not moving means we know that it's given that the weight is less than 23.62. Find the probability that weight is more than 80. So we can say probability of greater than 80. According to this definition of the conditional probability, we can say this is W is greater than 18 intersection, W is less than 23.62 divided by probability of W is less than 23.62. Right? Then we will try to get this answer. So in this case, this is the way. It's more than 18 and less than 23.62. Then the intersection is what? The intersection is in between these two. Okay, the numerator become probability of W is less than 23.62 and greater than 18. Divided by, this is probability of W is less than 23.62. Now, how to do this question? We know that here. This one you can say probability of W is less than 23.62 minus probability of W is less than 80. If you want to be the intermediate region, from the greater region, you would subtract the lesser region. Divide by probability of W is less than 23.62. So we know the probability of W is less than 23.62 is this bit of it. We already found this answer. The heaviest boundary is that one, 23.62, and the lesser region is 0.85 divided by 0.85 minus, we need to find this value. For the probability of less than 18, we didn't find it. So I need to find that answer. I'll try to find it here. Probability of W is less than 18, make them into standard normal by 18 minus, its mean is 18. This is the point I want to show you, divide by 5.4. That is the probability of Z is less than 0. That is, if you go to the table, Z is less than 0 is how much? 0.5. So simple answer over here. 0.5. So with this fact, you can get the final answer 0.35 divided by 0.85. Then answer should be 7/17. Right. Then when you come up to part D for this question, they mention a delivery of 4 packages is made to the factory. The weight of the packages are independent. Find the probability that exactly 2 of them will move by Gemini. That means when you're concerning about this, this is what, when you get the first package. First package may be transferred by Gemini or not Gemini. But the probability of transferring it by Gemini is 15%, 0.15. Then the not Gemini is 0.85. The second package, it can be Gemini or not Gemini, 0.15 and 0.85. This one also Gemini and not Gemini, 0.85 and 0.15 Gemini and 0.85. Third package, Gemini, not Gemini, Gemini, not Gemini, Gemini, not Gemini. So you know that all of them Gemini's ones are 0.15 and not Gemini 0.2. The next one is Gemini, not Gemini. You can just draw it. Gemini, not J dash, J dash, J dash, J dash. You can mark like this. J dash, J dash. When you come to S2, we learn some kind of like different configuration method for this, but for this moment, getting this is kind of easier for them. Now see whether you need to get exactly 2 of them will move by Gemini. That means 2 J dashes. This is not there. Make a pair. J dash. One combination here. J dash, J dash. Here. J dash, J. It's another one here. J dash, J dash. Another here. J dash, J dash, J. Another combination here. J dash, J. Here. Others are not coming with that. So how many ticks are here? 1, 2, 3, 4, 5, 6. 6 times of, in this case, all of them contains 2j's and 2j dashes. 2j's means 0.15 into 0.15 squared into not 2j dashes, 0.85 to the power 2. So with this, you can get the final answer for this, 0.15 squared into 0.85 squared into 6. Let's turn up to this bit. 0.0975 is the final answer for this. That's a way of doing this question. Right. A spinner can land on numbers 10, 12, 14, 16 only in the probability the spinner of landing on each number is the same. That means this is a uniform discrete distribution. Represent the inner spin line on the spinner sponge. State the name of this sponge. That is simply you can say this is it's a discrete uniform distribution. Discrete uniform distribution. Okay. Then write down the value for EX. But for this kind of information, EX, if it is uniform distribution, you can use the usual definition as well. X is 10, 12, 14, 16, and probabilities are given. It's each probability is 1/4 because all the probabilities are similar, and it's divided by 4 because it should be divisible by 4. There only 4 elements are there, right? Okay. Then what you can understand is when you talk about EX, you can say it's 1 mark. That means there should be a short form of it doing it. If it is a discrete uniform distribution, you can add these two corner values and divide by 2, you get the midpoint. 10 plus 16 divided by 2, 26, it's 30. Mean value is that. Then to find variance of X, you need to anyway work out. Anyway, we will get the EX squared first of all. How to find the EX squared? 10 squared into 1/4 plus 12 squared into 1/4 plus 14 squared into 1/4 plus 16 squared into 1/4. So you can say all the values are multiplied by 1/4. I will write 1/4 times of 10 squared plus 12 squared plus 14 squared plus 16 squared. It comes by 1 squared over 4 into 10 squared into 1/4. Like that, it comes over here. So EX squared becomes, see, that is simplification of the final answer. So nothing to worry with that. If you want, you can write as usual and get it is even into 1/4. Let's turn up to 174. Then we can get the value for variance of X become, what is the formula? EX squared minus EX, all things squared. 3x squared is 174 minus EX, we already found it as 13 squared. 69. The expectation become 5. Sorry, variance become 5. Sorry, I made a mistake. Then the next question. A second spinner is land on the number 1, 2, 3, 4, 5 only. These probabilities are given. The second random variable Y represents that the spinner lands on each spin. Find the probability distribution Y is given to the table below. That is, we can find expectation of Y and variance of Y over here. So you can simply write C1 is EY is equals to 1 into 3/13. Sorry, 4/13 plus 2 into 9/30 plus 3 into 6/30 plus 4 into 5/30 plus 5 into 6/30. And you can get the answer for EY. Let's turn up to divided by 30. It's equals to 3. EY becomes 3, expectation becomes 3. So to find variance of y, initially I need to find EY squared. How to get the EY squared? 1 squared into 4 over 30 plus 2 squared into 9 over 30 plus 3 squared into 6 over 30. I read the rest of it here. Sorry. 4 squared into 5 over 30 plus 5 squared into 6 over 30. Then you can get the EY squared plus 324 over 30. 324 over 30. Then we can get the value for variance of y is equals to EY squared minus EY whole thing squared. The EY squared is 324 over 30 divided by minus EY squared. EY is 3 squared. 315. 324 over 30 minus 905. 905 the variance of y over here. Okay. The random variable WV equals to AX plus B, where A and B the constants. They have given EWV equals to EY and variance of W equals to variance of Y. Find the value for A and B. It's pretty simple. This is the way. Initially, if you get this kind of input, this is, then they have given, if you need to get expectation of W, that is expectation of the WV equals to AX plus B input. That is AX plus B. That is, you can say A times of expectation of X plus B. Then we know that expectation of W, is equal to this. Then we can say expectation of W, they have given expectation of Y. Expectation of W, they have given expectation of Y. Then expectation of W, you can write A times of expectation of X. We already found it. Its expectation of X is 13. 13A plus B is equal to expectation of Y. Expectation of Y, we already found it. It's 3. This is my first equation. Then the other one is the variance of W is equal to variance of AX plus B, that is A squared into variance of X. Then variance of W is, you can say A squared of variance of X. We already found it as variance of X is 5. 5A squared is equals to variance of Y. Variance of Y, we already found it as 9 over 5. 9 over 5. Therefore, with that, you can say A is equals to 3 over 5. Then we can find the value for B. B is equals to, from this equation, you can say 3 minus 13 to 3 is 39. 39 over 5. It's turned up to minus 4.8. Give me 1 minute. Yeah, minus 4.8. Yes. It's the answer for B. Then each of the two spinors is spin once. Find the probability of WV is equals to Y. WV is equals to Y. So if you use this format today, this is another important, and sometimes most of students confused with this question in that specific year because it gave some kind of unexpected answer, as I remember.
Sir, I think you're muted.
Sorry. Right. So when you come up with this question, sorry, please excuse. Right. We know that here the W is 0.6, X minus 4.8. Right. Then if you come up with, this is a restriction for W. Then these are the X elements. Then we can see what are the respective elements of W for these individual X values. If X is 10, the W value is how much? 6 into 0.6 is 6, 4.8 is 1.2. If I put 1.2 over there, 0.6 into 12, sorry, 112 there, minus 4.8. So the respective Y value is 2.4. If I put 14 there, 14 into 0.6 minus 4.8. It's turned up to 3.6. If I put 16 there, you get the answer 4.8. Then these are the available W values for these questions. What are the Y answers? 1, 2, 3, 4, 5. Now you can see they request you to find the events where the W is similar to Y. You can see none of the W values are similar to Y. Therefore, this probability becomes simply 0 because none of W's are similar to Y. That's a fact we need to understand with this question. Okay. Right. Okay, we'll come up with this question. Just make it a little bit of smaller. You can see the entire question from small. Conduct, right? Okay. For this question, what they mention is a company director wants to introduce a performance-related pay structure for her managers. The random sample of 15 managers are taken from the annual salary Y in £1,000 as recorded in each manager. Director then calculated the performance score X for each of the managers. The results are shown in the scatter diagram in figure 1 in next page. Describe the correlation between the performance score and the annual salary. So if you come up to this one, now you can see it shows a kind of a positive relationship. It shows a positive relationship. Yeah. So you can say the simple answer for part A is we can observe a positive relationship. Straightforward look into the graph. We are not going to so hurry to describe about the strength of this one. So we can just say, yeah, it has a positive relationship, right? Okay. That means when the salary increases, the performance also increases. We can say like that. Okay. Right. Then when you come up to part B, the results are summarized in the following statistics over here. Show that SXY. So the simple formula is SXY is,
Sir,
yes. Yes,
so will it be possible for you to zoom in a bit? I can't see the questions.
Yeah. Sure. Yeah, hopefully this is fine with you. Okay. Right. Then the results are summarized below over here so that SXY equals to 2006. The SXY formula is summation of XY minus summation of X into summation of Y divided by N. Summation of XY we already knew, 19,428 minus summation X is 465 into 562, and this is done among 15 managers. So it should be divided by 50. So simply this is done up to 2006. So if you are sure about the substitution, nothing to worry, you just put 2006 without spending time on that. So B1. Then B2 is SYY. SYY is summation of Y squared minus summation of Y whole thing squared divided by N. Summation of Y squared we already found. 23,140 minus summation of Y squared is 562 squared divided by 15. So if you work out with this, you get the answer. Simplification comes with 2083.73. Right. Find the product movement correlation coefficient between the performances. We know that product movement correlation coefficient is SXY. We already found that 2006 divided by the square root of SXX. SXX given over here. 2492 into SYY. We already found it as 2083.73. So you get the answer as 0.8803. 8803. So you have a strong relationship. It has a strong positive relationship. The director believes that there is a linear relationship between the performance score and the annual salary, instead giving a reason whether or not this consists with the director's belief. Yeah, exactly this tally with the director's belief. What is the reason for it? Because there's a strong relationship. So you can write, since there is a strong relationship, his belief is true. That's a fact we need to believe is true. That's a fact we can write it. Since there's a strong relationship, his belief is true. Okay. Now let's go a little bit further. Then they mention the equation of the regression line y is given over here. You need to find the value for a and b. Okay, let's go ahead with this. You know that in the regression equation, if you do it E, the gradient B is given by Sxy divided by Sxx. Sxy over here is 2006 divided by Sxy. Sxy is Sxy is 2006 and Sxx is 2492. It's already given in the question. 2492. So that gives you an answer 0.805. Then you can get A is equals to y bar minus bx bar. Y bar means summation of y. Summation of y is 465 divided by 15 minus b is 0.805 into x by summation of x divided by 15. We already, summation of y is 552. Yeah, sorry, I will have to find what is summation y. Summation y is 562. So I made a mistake. This is 460. It's 465 x12. 562. 562, and this is 465 divided by 50. From this way, you get the answer as BA is 37.46. Sorry, 12.512. So you can get this answer. Then y equals to 12.512 plus 0.805x would be the equation of the regression line. Okay, right. Then give an interpretation of the value of b. Value of b means this bit. That means if the x factor is increased by 1 unit, what is the influence of y? That is what you mean by the gradient. Gradient means if the x factor is increases by 1 unit. So in this question itself, they mention x is the annual salary in 1,000 pounds, and y is the performance of the person. The complete director wants to introduce the performance salary structure of this mentioned. It's a salary y in 1,000 was recorded for each manager. The y can be calculated the performance of x. Performance of x means x. That means here, if the x is increased by 1 unit, what would be the increase of y? So you can say if the performance increases by 1 point, if the performance increases by 1 unit, the salary increases by 0.805 into, it's given in thousands, 805 pounds. That's a simple answer for this. That's a description of this, the figure. Okay, so with that, you can get the answer for that. Then, yeah, let's go a little bit down. The next question is, plot the regression line on the scatter diagram in figure 1. Yeah. Regression line on figure 1. So how can you do this? You can use this regression line for this. I'll be using the when x equals to 0. If x equals to 0, the y value should be 12.5. So I'll get this answer. It's 12.5. It's here. You can mark it's over here. And if x value is, we will take 50. The corner figure state getting is much appropriate. But the 12.512 plus 0.805 into 50. That's turn up to 52.7. That's obviously like 53. 53. Then what you need to do is you need to draw a line of base width, use a ruler and do it. I'm just do it manually, but so you need to do it perfectly. Okay. That's a line of base width. Right. Okay. Yes, right. Then if you go to the next part of the question, what they refer is the director hears that one of the managers, the sample seems to be underperforming. On the scatter diagram, scale the point where the best defines this manager. So you can see that is the most exceptional information. Is the most exceptional information. Therefore, that is the one where it does not tally with the existing value, which shows the underperformer. The director decides to use a regression line to the performance to relate to the pay structure. Estimate for the figures that the salary manager with the performance score 30. Yeah, that means it's pretty simple. You can say I is, you can substitute 30 into this. Y equals to 12.512 plus 0.805 into 30. You can say 12.512 plus 0.805 into 30 into 1000, because why it's 1000 because it's given in 1000. So it's come up with the y value is 36.662. Therefore, it's that is given in 1000. Therefore, its amount is 36,662. It's a final answer for this. Okay. This is one of another crucial question where they come across. So most of the students couldn't perform really good in this question. So we had to be a little bit concerned on this one and try to get a good answer for this. Right. Look at it. A disk of radius 1 centimeter is rolled into the horizontal grid of a rectangle so that the disk is equally likely to have land anywhere on the grid. Each rectangle is 5 centimeters long and 3 centimeters wide. That means it's 5 centimeters long and 3 centimeters wide. Okay, this is 5 centimeters and this is 3 centimeters. The what do you call? There is a disk. Disk has a radius of 1 centimeters. 1 centimeters. That's the point we need to understand with this. Right. Then, by concept, if the disk lands outside of the rectangle without covering any part of the edge of the rectangle, then price is what? You need to put this one inside, exactly inside over here. If they like some kind of like something, this kind of situation is not accepted. That is a point we need to understand in this question. Right? Show that the probability of winning a prize on the particular roll is 1/5. That means, the edges, we have to be very concerned about the edges. So you can see if it is placed in the corner like this, you can win it, but not with any other thing. That means it should be here. This corner, the maximum you can go ahead is like this. 1 over here. Here 1 and 1. Here also 1 and 1. This corner also in between 1 and 1. And this corner also it can be 1 and 1. That means if the center plays somewhere between this boundary only, you can win a game. Definitely it should be placed in between this area. That means the center should be definitely fall into this area out of the total would be the winning way. So you can say probability of winning would be this area. But what is this area over here? You can see total length is 5 centimeters. Out of that, you can remove 1, 1, 2. There should be 3 centimeters. This height is 3. It's turned up to 3 minus 1 and 1. But the scale is wrong today. It's 1 centimeters. If it falls in between this area out of the total area would be the only winning chance. So in between whatever the place you put it, you can win the game. So it should be 1 into 3 divided by 5 into 3. It's turned up to then 1 over 5 would be the final answer for this question. That is a way of getting the winning by placing this roll into this disk. That's a way of getting the answer for part A. Then part B. A group of 15 students in each roll the disk into the grid 20 times and record the number of times X for which the student wins a prize. Their results are summarized as follows. X equals to summation of 61 and X squared is this much. Find the standard deviation of the number of prizes won by a student. So you can get the standard deviation is sigma squared is, variance we can find summation of X squared divided by N, summation of X divided by N, whole thing squared. So summation of X squared is, you get the answer as 295 divided by 15 because it's done by 15 students minus 61 divided by 15 whole thing squared. That should be the value sigma squared. So you can get the answer as 3.1288. Therefore, the standard deviation become the square root of that one, 3.1288. So the standard deviation is, according to this one, is 1.77. 0.77 would be the standard deviation for this. A second group of 12 students each roll the disk into grid 20 times and the mean number of prizes won by first student is 3.5 and the standard deviation of 2. Find the mean and the standard deviation of the number of prizes won per student for whole group of 27 students. Then 15 students each roll the disk into the grid 20 times and this one also into the grid time. Okay. Then what they want is find the mean and the standard deviation of win for out of 27 students. So what you can get here is initially we can do it in this way. I need to find the total mean. We know that combined mean is X bar combined is equals to X1 bar into N1 plus X2 bar into N2 divided by N1 plus N2. Can you get this answer? That's the formula where we get it. Okay. Then let's try to work out with this. Yes. Then the first one, the summation of X is 60. Mean that's the mean is not given, but they have given the sum of 61, sum of this one. So we can work out with 61 over here. Plus the second one, they placed the mean of 3.5. The over there, the mean of one of the second group of 12 is 3.5. For the second group, it has turned up into this bit. There the mean is given of 3.5 out of how many students? 12 students. 12 divided by N1 should be The first one is 15 plus second one is 12. And you can get the answer with that. But it's 61 plus 3.5 into 12 divided by 15 plus 12. It's turned up to 3.81. The new mean become 3.81. That's the answer for that. Right. Then when you're working out with the standard deviation of 2, the new the first set standard deviation we already found it today. There is sigma first set. Sigma squared, I'll get the first set. We already found that answer today. In the previous question, we already gotten that answer as 1.77. Sorry, sigma squared is 1.76. Sorry, 3.12. 3.12. And the second set, the sigma squared for the second set is today. They mentioned standard deviation of 2 means it should be 4. Then they are referring, they want to get the standard deviation of the new set. Initially, I need to find the total set. Sigma squared of the total set would be this summation of new set. Summation of I will get the new variable as a squared minus summation of a divided by n minus summation of a divided by n whole thing squared. This was the formula. So I need to find the summation of a squared for both of these sets. I need to find the summation of x squared for the both of these sets. Then how do you want to find this value? Then summation of x squared of the first set we know that is 295. Sorry, that is 295 for the first set we know. 295, but for the second set we don't know this value. The standard deviation is 2 mean for the second set if you write sigma squared 2, that is summation of y squared over n minus summation of y over n whole thing squared. We know this fact. Make a 4 here. This value we know it's 4. Still we don't know what is the summation of y squared divided by n. Divided by n is it has done out of how many students? Second set there are 12 students. 12 minus the mean value we know. Sorry, mean value is 3.5. 3.5 squared. From here you can get the summation of y squared. Summation of y squared you can get 4 plus 3.5 squared into 12. That is 195. Therefore, you can add another 195 over here. Divided by n is now total number of information. First set 15 and second set 12. Minus summation of a, the mean one. The first one, the mean is, we already found the combined mean, sorry. Not it of working out this Kelly 3.81 squared. Straightforward, you can write it as 3.81 squared. Then let's work out this and see whether what would be the final answer for this particular. 295 plus 195 divided by 27 minus 3.81 squared. That gives you 3.63. 3.63. Therefore, the standard deviation of the new set would be the square root of 3.63. Then you get the answer as 1.89. The 27 students also recorded the number of times that they discovered the corner of the rectangle and estimated the probability to be this big. Explain how the probability could be used to find the estimate for the value of pi. Just state the value for the estimate, right? Okay. That means, but they already found the probability of falling at the corner. The center falling at the corner means, but it should be like this. Like this. The probability of falling like this is, they already found this probability as 0.2214. Then probability of falling at the corner. Falling at corner is area enclosed over here. Area enclosed over here is how much? Let's say it's a 1/4 of a circle. Radius is 1. What is the area over here is pi into 1 square divided by 4. That is pi over 4. How many of them there? There are 4 such values over here. Divided by the total area. What is the total area? The total area is 5 into 3. So this is turned up to pi over 50. Okay, that is the fact we need to get it. But they have given this one as 0.2216. 5 over 15 is equals to 0.2216. With that, you can find the value for pi. 2216 into 15. 0.2216 into 15. It's 3.324. Roughly that's the answer. That's a way of getting this answer.